we are still on first order ordinary differential equation. Now, previously we've talked about order and degree. We've talked about solutions to ordinary differential equation. And I told you basically we have 6 solutions. I gave you the integrating factor, the Bernoulli, the exact solution, and so on. But today we'll talk about what? The application of first order ordinary differential equation. We are not on second differential, we are on what? First differential. So all our equation will be in the first degree, which is what? The y over what? The x. Now, for the applications of first order ordinary differential equation, we have various applications to first order ordinary differential equation. The first one we have is what we call root and decay. So we use first order ordinary differential equation in solving problems dealing with what? Root and decay. The second one we'll be talking about is Newton's law of cooling. Newton's law of cooling. The third one is what we call the RT, RL, and LC circuit. Now we're talking about how we can apply the first order ordinary differential equation in solving problems dealing with what? Growth and decay, Newton's law of cooling, RC circuit, RL circuit, and what? LC circuit. Now we still have more. We have another one called mixture problem. Mixture problem. And also we have the last one, which we'll be talking about, which is what? Falling objects. But the application we'll be talking about in today's class will be the one for what? RC, RL, and what? The LC circuit. How do we apply first order ordinary differential equation in solving these problems? Now the first one we take is what we call the RC circuit. Now let's talk about the RC circuit. So the first one which we'll be talking about is what? RC, RL, and LC circuit. Now why I'm doing this is because this was what they were taught. This was what you were taught in class. So now let's talk about the RC, the RL, and the LC circuit. How can we apply first order ordinary differential equation in solving problems? Now the first one is RC circuit. Now if you ask, what is the RC circuit? Now for the RC circuit, for a circuit to be RC, it means that circuit has the combination of what? Both resistors and what? Capacitors. So you have resistors, the combination of one or two what? Resistors with what? A capacitor. So for the RC circuit, take this down. The RC circuit is a circuit that has both combination of what? Resistors and capacitor. The RC circuit is a circuit that consists of what? Both what? Resistors and what? Capacitor. So if you have a circuit of this manner, this one is used to represent what? Resistor. And this is used to represent what? Capacitor. Now we have the resistor, now we have what? The capacitor. Here we have what? EMF. Now for the combination of both resistors and capacitors, we'll be calculating for what? The total voltage in this circuit. What are we having here? EMF. And when we are talking about EMF, our concern is what? The total voltage flowing in this circuit. So we have to calculate for the voltage for what? The resistor, and the voltage for what? The capacitor. So what will be our total EMF? Our EMF represented as big E will be equal to VR plus what? VC. Where VC is what? VC is what? Voltage in this capacitor, and VR is what? Voltage in what? In the resistor. Now recall, when we talk about capacitor, we talk about what? Quantity of charge. Now quantity of charge is represented by what? Q. And Q is equal to what? CV. from elementary physics. Now, if we know CV to be what? Quantity of charge. Can we get the voltage of what? That capacitor. Now, to get the voltage of a certain capacitor, VC, which is voltage of that capacitor, is equal to what? Q over C. That we just made what? We made V the subject of formula from this equation. Now, but recall from Ohm's law. What is Ohm's law? Ohm's law. From Ohm's law, V is equal to what? IR. When calculating for resistor, we talk about what? Quantity of charge. But for a resistor, when we are talking about the quantity of charge, we are talking about quantity of charge with respect to time. So to calculate for quantity of charge with respect to time, it is what? Q is equal to what? IT. Where I is what? Our current, and T is what? Time. So can we make current from this equation subject of formula? Now making current here, we divide it by what? Divide here by T, we divide here by T. So this is cancelling out. So I is equal to what? Q over T. Where your I is what? Your current. Q is what? Your quantity of charge. T is what? Your time taken. Now, but we are not interested in getting the total current. We are interested in getting what? Instantaneous current. To get your instantaneous current, what do? We differentiate. Now, differentiating, we have what? For instantaneous current, which is what? Small I is equal to what? dq over what? dt. That is the formula you use to get what? Your instantaneous current. Now, from what you have here, you know that we'll be calculating for what? Voltage, which is what? IR. Now, can we say that I here is this I we have here, and what? Time multiplied by what? Your resistor. So your VR, which is voltage for your resistor, which is this, is equal to what? IR. But we've calculated for I, and I is what? dq over dt. So your VR is equal to what? dq over what? dt bracket what? Your VR. But recall, how do we calculate for what? Your total EMF. We said total EMF, which is what? E is equal to what? Voltage of the resistor and the voltage of what? The capacitor. We are interested in calculating for voltage when we talk about EMF. Now, applying what we have here, we simply have what? E, which is your total EMF, is equal to what? VR plus what? VC. That's what we have here. So if you substitute these parameters which we got, we simply have that what? E is equal to what's your VR? We know that VR is what? dq over what? dt. So we have that what? dq over what? dt bracket what? R plus what is our VC? Now voltage for what? For the capacitor is what? Quantity of charge divided by what? Capacitor. So now this formula is the formula you use in calculating what? Your total what? EMF for this circuit. Now let's take some examples for more clarification. Now take this down. The capacitor 0.05 farad in a series RC circuit. The capacitor 0.05 farad in a series circuit with a resistor 80 ohms. With a resistor 80 ohms is to be discharged. Find the time when the capacitor has lost half of its initial charge. Now looking at our question, the first thing is what? Example 1. We have a circuit. This is your circuit. Now in your circuit, we have what? Resistor and what? Capacitor. And they are connected what? They are connected in series. Now we know that these are resistor and these are what? Capacitor. Now, what were the parameters given? What is the first thing?
0.05 farad.
Now, they gave us the resistor to be what? 80 ohms. And they gave us what? Our capacitor to be what? 0.05 what? Farad. Now, in that question, did they give us EMF? They did not give us EMF, so we take our EMF to be what? 0. Now, what was the question? The question was, let's calculate the time for what? For your capacitor to discharge half of its initial charge. That is, it means what? We should calculate for T units when what? Our capacitor discharge what? Half of its initial charge. And we know that for initial charge, you can either represent it as QO or QIL. But let's represent it as QO. But when T is equal to 0, our Q is equal to what? Our initial charge. That's the meaning. Because if they tell us to calculate for the time, and they gave us what the capacitor discharge, and they said the capacitor discharge was half of what? Its initial charge. Now, what is the time at 0? Now, to calculate for your time at 0, it will be what? Your capacitor will discharge what? The initial charge. Now, if your capacitor will discharge your initial charge, how do you calculate for this time? Now, to calculate for this time, recall that what? Our total EMF is equal to what? Voltage of the resistor plus what? The voltage of the capacitor. I told you earlier that when we are calculating for EMF, we are interested in our voltage. Now, if we do that, we'll simply have what? E equal to what? E is equal to what? VR plus what? VC. Now, if we do this, we know what VR is. From this point, we know that VR is what? dQ over dt. So if you substitute what we have here into this equation, we'll simply have what? Our E equal to what? What is VR? dQ over what? dt. All the plus what is our VC?
Q.
We know our VC to be what? Q over C. But in our question, they gave us our resistor, which is 80, and they did not give us what? They gave us C, which is what? 0.5. Now let's do that. Now from what we have here, we know our resistor, which is what? 80. We know our capacitor, which is what? 0.5. So let's substitute what we have here, and we know our what? E, which is what? 0. So substituting what we have there, we simply have what? 0 is equal to the Q over what? The T bracket. What is our resistor? 80 plus what?
Q
over what? 0.05. Now we can rewrite this equation by saying what? 0 is equal to the Q over what? The T bracket what? 80 plus what is our Q? This is 1 over what? 0.05 Q. Now punch what you have here in your calculator. If you punch this, you will simply have what? 0 is equal to the Q over what? The T bracket what? 80 plus what? 1 over 0.05 is what? 20 Q. Why left it? You can rewrite your equation where your what? Your dq over dt will stand first, your 20q and your equal to sign. So if you rewrite this equation, you will have what? dq over what? dt bracket what? 8 plus 20q equals to 0. What do we do? We can do something to your equation. We can simplify it. And how do we simplify it? We are seeing 80 here, we are seeing 80 here, and we are seeing 80 here, we are seeing 20 here, and this is equal to 0. All of them, they are what? Even numbers. So what do we do to remove these even numbers? We can divide it by what? By your 20 here. So if you divide it by 20, the next thing is what? Divide through by 20. If you divide through by 20, you simply have what? The q over what? The t. 80 divided by 20 plus 20 cube divided by what? 20 equal to 0 divided by what? 80. So if you do that, your 20 is removing 20. 0 over 20 is what? 0. 80 divided by 20, you have 4. So if you do that, you simply have what? 4 the cube over the t plus you are left with cube, and this is equal to 0. Now, look at what you have here. What solution can you apply to solve this problem? I taught you how to use integrating factor to solve problems. I taught you how to use separation of variables to solve problems. And I also taught you how to use direct integration to solve problems. Now, from what we have here, the q plus what? The q over what? The t plus q. What can you recall? This thing is the same thing as your integrating factor. Now, applying the concept of integrating factor, what do? We compare. Now, comparing, I told you, when you are comparing we are comparing what? Y over the x plus what? Py equal to what? Q. But in this case, we are not interested in y and x. What are we interested in? Q and t. So since we are interested in Q and t, we can substitute anywhere we see y and x, we are substituting what? Q and t. So doing that, we simply have that what? We are comparing with this equation. The q over what? The t plus pq equal to what? Your bq. Because that's our interest. Since this is our interest, we are comparing this with what we had here. But let's rewrite this equation to see something. Now let's rewrite what we have here. Now, if we rewrite what we have here, we simply have what? P dq over what? dt plus q equal to 0. What are we comparing? We are comparing this and this. But if you look at this question, your question is not what? Is not in order. So we can simplify this before we compare. Now, when I mean simplifying this, we want to make the q over dt stand alone. Now, making the q over dt stand alone, what do? We are dividing 2 by what? By your 4 you are having here. So if you divide 2 by 4, your dq over what? Dt is standing alone. So the next thing is divide 2 by 4. Now, if you do that, you are simply having what? 4 dq over what? Dt divided by 4 plus what? Q divided by 4 equal to what? 0 divided by 4. If you do this, you simply have 4 cancelling 4. So you are left with the q over what? Dt plus 1 over 4 q equal to what? 0. Because 0 divided by 4 is what? 0. Now, looking at your equation here, you can see that what you have here is the same as what you want to compare. So now you can compare what? Perfectly. Now, comparing your equation, I told you in integrating factor that when you want to compare, you are comparing to get what? Q and you are comparing to get what? You are comparing to get what? P and what? Q. Now, if you compare to get P and Q, what are we comparing? Our PQ will be equal to what?
1 over 4Q.
1 over 4Q. And our Q from there will have what? 0. The next thing, while solving integrating factor, I told you, after comparing, to get your what? P and Q. But here we are getting what? PQ. What do? We remove this Q. Now, to remove this Q, we simply what? Divide 2 by Q. We are left with what? P equals to what? 1 over 4. What is the next thing? I told you when solving integrating factor, you apply your if statement. And the if statement you want to apply, you are applying the first if statement. Now let's apply that statement. To apply your if statement. And we know that our first if statement is if equal to what? Exponential integral of what? P dx. But in this case, we are not using x. What are we using? T. So it will be what? If is equal to exponential integral of what? P to t. We've gotten our P to be what? 1 over 4. So you simply take 1 over 4 here into this equation. If you do that, you simply have what? Your E to be exponential integral of 1 over 4 dt. Now the next step is to solve for this, which is your power. So the next step is solve for what? Integral of 1 over 4 dt. Now, if you solve for this, you simply have what? If you integrate 1 over 4, you simply have what? 1 over 4 multiplied by what? T. This is what you have. And I told you we cannot add c here because we are not done with the equation. And even this is the last part of the equation, we are going to add c to it. Now, if we substitute what we have here to be this power we solve for into this equation, we'll simply have our if to be what? Exponential 1 over 4 t. Now, what is the next thing we have to do? The next thing is apply the second if statement. And the second if statement says what? Y dot what? If is equal to integral of what? If dot q dx. That was our y, our second if statement. And I told you in this statement, we are not using what? X and y. We are interested in what? Q and what? dt. So what we'll do is you rewrite your equation to be what? Q dot what? If is equal to integral of what? If dot q dt. Now, we'll simply get the value for y for if and we'll get the what? The solution for what? Q. We know that our q is what? 0 and our if is what? Exponential 1 over 40. Now, if we substitute these parameters, we'll simply have what? Our q dot what? If, and if is what? Exponential 1 over 4t. And this is equal to integral of, what is our if? Exponential 1 over 4t dot what? Q dt. We know our q to be 0. So you can rewrite this equation to be what? Q exponential 1 over 4t, and this is equal to your integral of exponential 1 over 4t dot what? 0. Our q is 0, so we can substitute 0 there, dt. Now, if you see what we have here, we have 0 multiplying everything you have here. Now, if you have everything here to be 0, you are integrating 0. And if you integrate 0 is what? 0. And after integrating, what do we add? We add plus c. So if you do that to this side of the equation, you simply have this to be what? Q exponential 1 over 4t is equal to, you have integration of 0 here. So it will be 0 plus what? C. Now, what is the next thing I told you in that equation? Go back to your equation. I told you after applying your second if statement, what do you get? You get y. But in this place, what are we having? Q. So let's make Q subject of formula from that place. Making Q subject of formula, you are dividing Q by what? Exponential 1 over 40. So if you do that, you are dividing here by what? Exponential 1 over 40. And you are dividing here by what? Exponential 1 over 40. Now, if you do that to this equation, this will be what? 0 over exponential 1 over 40 plus c what? Exponential 1 over 40. Now, if you do that to this equation, you will simply have this to cancel this. And on this right hand side, you are left with what? Q is equal to 0 divided by exponential 1 over 40 plus c over what? Exponential 1 over 4t. What do we do? This is already 0. So you are left with q equal to what? C exponential 1 over 4t. Now go back to the first part of the note. I told you you are giving t to be what? 0 and q to be what? Q naught. That's what the question says. Now, meaning anywhere you see q, you are putting what? The q initial. And anywhere you see t, you are putting what? 0. Now, putting this into this equation, what are we to find? We have to find what is c. Now, if you find what is c from what we have here, you know that our q is what? Q naught. So we have q initial is equal to c over what? What's your exponential? Exponential 1 over 4. What's our t? Bracket 0. Now, if you solve what you have at this top side, you simply have q initial is equal to c over what do we have here? Meaning 0 multiplying with what we have here, we have exponential 0. From elementary maths, we know that anything raised to the power of 0 is what? 1. So if you have that, you simply have q naught is equal to c over 1. And q naught is equal to c over 1 is c. Now, you have c here. as what? Our Q naught. So can we use this equation to solve with the second condition I gave you? Now what is the second condition? That was what our question was saying. They said we should find for t when our Q is our what? Initial charge. Now if you do that, we simply have what? T to be unknown. T is what? Unknown. And they gave us Q to be what? Half of our what? Initial charge, which is Q naught. Now if you substitute these parameters into what we have in this equation. Now in this equation, we've already known what is Q. We've already known what is this. We did that. From this, we used to prove that our Q initial is what? Is equal to C. Meaning that anywhere we have C, we can put what? Q initial. Now let's put Q initial in anywhere we have C, or we use C to put our Q initial from this equation. Now from what we have here, let's use this condition to solve further. Now we know that from here, we know that Q is equal to C over exponential 1 over 4t. Abi? Now, we've already gotten the value of Q, but we don't know what is t. We have to find t now. Now to find t, we know that our C is equal to what? Q naught. So meaning anywhere we see Q, anywhere we see C, we have to put what? Q naught. So if you do that, we simply have what? Q is equal to what? Q naught over what? Exponential 1 over 4t. What we have here, we know that Q is equal to what? Q naught. So here we also have what? Q is equal to what? Half of what? Q naught. Meaning anywhere we are seeing Q, we have to put what? Half Q naught. So we are removing this Q here to put what? To substitute what? Half Q naught. So if you do that, we simply have what? 1 over 2. And what is our Q? Q naught here. Q naught is equal to Q naught over exponential 1 over 4t. Note, this question that they gave us, we have to calculate for the time. We have to calculate for what? The time. So we are still looking for this time. That's why we are proving all this. Now we are proving all this for the sake of what? Because we had what? We had what? An equation that they gave us that had to do with what? Integrating factor. So you need to use your integrating factor solution to solve that problem, to simplify that problem. That is what we did here. Now if you do that, what do we arrive at? We arrive at this point. And now we want to use those conditions that they gave us to get what? Our time and our what? Charge. Now from what we have here, we simply have this to be what? Q naught over what? 2, and this is equal to Q naught over exponential 1 over 4t. We are seeing Q naught over 2 here, and we are seeing Q naught over what? Exponential 1 over 4. So we can simply remove this Q naught here and remove this. If we do that, we simply have this to be what? 1 over 2 is equal to Q naught over what? Exponential 1 over 4. We simply have what? 1 over exponential 1 over 4t. But we know that from elementary maths, if we have 1 over anything, what is that? That thing raised to the power of what? Negative 1. So we can rewrite this equation to be 1 over 2 equal to what? Exponential 1 over 4t raised to the power of what? Minus 1. Now looking at what we have here, we are seeing what? 1 over 4t raised to the power of minus 1. So you can use this minus 1 to multiply what we have here. We'll simply arrive at what? 1 over 2 is equal to exponential minus 1 over 4t. Now, we have a complicated issue here in mathematics. What do we do? To remove exponential, what do? We apply what? Ln. Now, if we apply ln to this equation, we are simply having what? Ln 1 over 2 is equal to what? Ln exponential minus 1 over 4t. We can simply what? Our ln can remove the exponential. Now what do you have? You simply have what? Your ln 1 over 2 is equal to what? Minus 1 over 4t. What do we do? Our interest is to get what? Our t. So we can take this to this other side of the equation. But before we take this, let's simplify ln 1 over 2 first. So you can punch this on your calculator. Punch ln 1 over 2. Now if you punch ln 1 over 2 from your calculator, what will you have? You have minus 0. What? 69332 is equal to minus 1 over 4 t. Our interest is to get t. So now punch 1 over 4 in your calculator. Now if you punch 1 over 4, you have what? 1.24. So you have minus 0.693732 equal to minus 0.25 t. We are having minus here. So this minus can remove this minus. What are we left with? We are left with what? 0.6932 equal to what? 0.25 t. What do we do to get our t? We want to make t subject. So you are dividing this by what? 0.25. And you are dividing here by what? 0.25. Now if you do that, we'll simply have this to remove this. You are left with what? T equal to what? 0.6932 divided by 0.25. What will your t be?
2.773.
So your t will now be what? 2.773 seconds. So now we've arrived at getting our t. Now we can successfully say what? At t equal to what? 2.8 seconds. We have q to be what? Half of what? Its initial charge. And that was what we were asked to get.